very happy today to welcome Dean to come talk to us and give us a workshop tutorial series on DVC, which I believe is version control for data science models and data sets. Dean is the CEO and co-founder of DAGS Hub. I believe we've already had another talk by another DAGS Hub person talking about how they've actually contributed and made a lot of interesting interactive stuff to do with Jupyter Notebooks. So we're super happy to have Dean, again, CEO of DAGS Hub, to come and talk to us about this. Thank you. I'll hand it off to you.
Awesome. Thank you for the introduction, Conrad. It's really a pleasure to be here and take part in this awesome conference. It's also really good to see so many people join into the call. So I'm guessing you're curious about data versioning practices, and I hope I'll address all of your questions and things that you're interested in during this talk. As I mentioned, if you joined before this or after this, rather, if you have any question, then feel free to stop me in the middle and ask. I might say that I'll address those later, but you can also ask via your own voice or type it in the chat, and I'll try to address it as I go along. So the title of my talk is Who Moved My Data? And this is going to be a data version control showcase. So the overarching topics that we will address are at a high level, why reproducibility and data version control matter for your day-to-day lives. We'll discuss an overview of DVC, so basic operating principles and how that looks and feels. And then we will crack open the hood and look underneath and understand the basic DVC operating principles. We'll discuss working with DVC remotes, which basically expands the capability of data versioning into teamwork. If you are familiar with the term data-centric AI, which is now growing in popularity, this is one tool to be more data-centric. We'll then discuss using DVC to ensure reproducibility of your data science pipelines. And then, like everything, no one is perfect and no tool is perfect. So we'll discuss why and when you should use DVC, what are its pros and cons. And then finally, we'll also review a tool called FDS, or Fast Data Science, which combines DVC and Git into one. And so that is going to be I'm going to talk about all of these topics, and then we'll have a hands-on demo, which is going to be a notebook that I'll share with you during this call, so you can open and follow along, where we'll review those things and practice what we preach. So it's not just theoretical and high level. So that's it, and let's get started. So a few words about me and my background. It's a combination of physics, machine learning, and computer science. I am really passionate about building tools that help machine learning teams work together. And I'm even more passionate about the role that open source has to play in the world of machine learning. But in general, I'm a strong believer in open source software. I am also the co-founder of DAGS Hub, where we are building a GitHub for machine learning. We're taking amazing and popular open source tools for ML and combining them into a platform that makes them easier and more convenient to use, as well as adding abilities and workflows needed to work with them as a team. And then I'm also the host of the MLOps podcast, where I speak with industry experts about bringing machine learning into the real world. And this is also to address the necessary question of why should you listen to me? One of the tools that we're integrating closely with in DAGS Hub is DVC. So I'm very familiar with the tool and its internals. But on the other hand, I have had the chance to review and use many other tools in the industry. And so I have a broad perspective on tooling in the ML market, in my opinion. And then I also welcome you to follow me on Twitter or on LinkedIn, where I share more about all of these topics that I just mentioned. Cool. So a motivation. I don't know if everyone here remembers this statistic. This is kind of a semi-regurgitated fact, which is not necessarily true about the data science world. This was probably true 2 years ago, or closer to true 2 years ago, but people like to say that 87% of data science projects never make it to production. But I would argue that this is no longer the case. And we ran this poll with over 2,000 votes from industry professionals. And we see that over 80% of teams already have models in production, and 25% of them have more than 10 models in production. And so that means that if you're listening to this talk and you're working as part of a data science team, your team probably has a model in production already. And if it doesn't, it will probably have one in the not too distant future. And so if a few years ago, everyone was looking at Google and Amazon and Facebook and saying, like, I want what they have with respect to the data science sort of tooling and workflows, today, even small startups, even traditional organizations that have data science teams are already getting to production. And that means, that basically you sort of understand that many aspects of real data science and machine learning work starts when you deploy that first model into production. So at that scale, things tend to look a bit different from the proof of concept stage. And so holding together things with duct tape might have gone fine at that point, but it's no longer productive to do that when you're deploying your 10th model into production. So Laszlo, hey, commented that the 87% was via statistic originally, and I tend to agree. So I don't like that statistic, but I would say that sort of the overwhelming vibe that you would get a year and a half ago as sort of an ML practitioner is that most organizations are sort of in the proof of concept stage. So they have something, they're not sure how to get it to production. And so what I'm saying is basically that there has been a shift. And so now, if I had to choose sort of something which is a major thing that's holding the field back, is that we don't have sort of a standard workflow. And so you want to sort of automate the process of iterating on machine learning models. So not just automating your training pipeline and your deployment process, but also the iteration itself. And so you need flexible tools to solve these challenges. And I would argue, and this is basically the main argument that is backing sort of reproducibility and data version control, that reproducibility is one of the main challenges that we have to deal with in order to get to this promised land of a standard workflow. And so basically what we're missing today is we want to connect to the existing production setups so that we can have a real impact on the organization that we're in. And then if your machine learning lives on a separate planet, everything is going to be very slow and very painful. The second thing is everyone is talking about hashtag data-centric AI, but in practice, many teams don't have proper access to their data. And it's treated as a second-class citizen in many cases. So I've spoken with data scientists in the last 2 weeks that basically said that they want to be data-centric, but they have to talk to 5 different people in their organization just to play around with their data in a context which is not an automated pipeline, and that doesn't make sense. And finally, we're sort of disconnected from each other. So obviously more models in production means growing your team. But if the processes that make it possible to grow your team are vague or broken, then you're going to have a bad time. So if we are in misattributed statistics and quotes, I'll take Albert Einstein's misquoted, insanity is doing the same thing over and over and expecting different results. So Einstein didn't really say this. I'll let you, give you a moment to let that sink in. But the gist of this sentence is something that I very much agree with, which is the ability to rerun a project and get the same results is at the base of standardization. And in that context, you sort of really want to get the same result when you're rerunning your project's code. So you want to work in a sane way. And so this is sort of a prerequisite to preserve your sanity while working on machine learning. Then the increase in complexity requires better handling and engineering. Otherwise, things will break more often. And maintaining reproducibility will make it easier to debug and audit your own work. It is also a prerequisite for teamwork, as I mentioned, in the sense that it helps remove single points of failure in the system. And it makes it so that not every task is a cold start, meaning if you have a new task now, then you don't have to start as if this was a new project, but you can actually pick up where someone left off, whether it's you in the past or someone else on your team. And then finally, in many ways, the best way to treat data as a first-class citizen means treating it the same way we treat our code. So it logically follows that we should version our data with the asterisks that we're going to discuss later. And so, sorry. Yeah, the videos are disappearing. So the good news is that we don't have to start from scratch. A lot of time has been spent and a lot of mental blood has been spilled to produce tools that manage code workflows, do code version control, and then define the best practices within the realm of software engineering. And this is not to say that we should accept everything coming from software engineering as the word of God. But as a rule of thumb, reinventing the wheel is a strong sign that we might have taken a wrong turn. And so usually if you find yourself saying, yeah, we should rebuild everything from scratch, then it's probably sort of a good idea to check whether or not there are good solutions for that issue sort of beforehand. And finally, sort of Git specifically and version control in general were arguably the start of the solution for complexity in software engineering. And so an entire world of GitOps, CI/CD, infrastructure as code were slowly built on top of that, enabling sort of automations and relatively speedy iteration process and teamwork at scale. So now let's dive into the details. So how does data version control fit into this whole thing? And I guess before that, one side note, in this entire talk, when I say data versioning, I mean data and artifacts. And that means intermediate results. So if you're pre-processing your data, your raw data, then the intermediate results are also considered data for the purpose of this talk, but also models are something that you version. So in some cases, I'll say model versioning explicitly, but even when I say data versioning, I mean this in the broader sense of like the artifacts and the data that we have in our process. And sort of the main mental model that I propose is relatively straightforward, which is treat your data as if it was source code or a part of your source code. Stop thinking about version control only for code, i.e. text documents that are sort of limited in size and amount. And even if you don't change anything, like you disagree that DVC is a good tool, you don't want to use it, or maybe it's not suitable for your use case, that's okay. But starting to think about data as part of your source code is going to educate the decision-making process you do in the future. And I think that's going to be useful. And so once you do that, the next shift is sort of starting to think about combining code, data, models, configurations, metrics, all in one version. And that is also the DVC approach, whether formally or under the hood. And so in other words, every experiment is a commit. And I think that is good for a lot of use cases. It does not fit all of them. And so I'll try to address this as well. And if I forget, then please remind me. So what is DVC? Oh, sorry, this is the animation. So what is DVC? DVC is short for data version control. It is a command line tool for data science and machine learning version control and reproducibility. And DVC also now offers some basic experiment tracking capabilities, but I don't think that that's sort of their core focus. And so we won't focus on those capabilities in this talk. We're going to focus on, again, versioning and reproducibility. And I guess maybe this is a good time before I dive into the technical details. Any questions so far? I'll take a sip of water. Okay, cool. So the first objection that you might have to everything that I just said is, why can't I just use Git and Git LFS for this task? And so for Git, the question is pretty straightforward. It's just not good at handling large files, and especially binaries. It's not built for that. Git LFS is a bit more nuanced. It has its limitations as well, but I would argue that first and foremost, it's not optimized for data science work. It doesn't have the data scientist as the first class sort of user of the tool, and it misses some clear preferences that developers and data scientists have. The simplest example of this is that Git LFS requires that you work with a dedicated Git LFS server instead of working with the cloud storage options that are widely used. And I would argue that DVC's version control capabilities for data are sort of like a better version of Git LFS. This might be a hot take. I know that there are a lot of people that love Git LFS, but again, you're not here to listen to things that you already know. And I think that really we can see this in sort of the usage of these different tools. So DVC is basically, at a high level, a tool that extends Git sort of seamlessly. And I emphasize extends because DVC relies on Git for managing the versions. And we'll see how that works in a moment. So you can track all of your large files, whether it's data, models, artifacts, even metrics. And this flexibility also means that creating something like a model registry, which is now also a term that like a capability that a lot of teams and data scientists want, has the same flow as tracking a data set. And so it's really versatile. Reproducibility is built in, specifically with DVC's pipeline feature, which we'll cover. And it's built to handle large files and use the common remote storages without any sort of dedicated servers in the middle. And of course, it's open source. So a lot of awesomeness here. And now we get to the heart of things. So how does DVC work? And before we look under the hood, I want to give an example at a high level of the sort of operating principles of DVC. So let's say we have our sort of local file system. We have our Git remote and our DVC, our Git cache and our DVC cache. And this can also be our Git remote and our DVC remote. I'll talk about the differences. But let's say we have this really, really large file. It contains the secrets of the universe, and we want to track it. And so we're going to use DVC to track that because that's what it's optimized for. And so what we're going to do is we're going to run a command, which is DVC add. I'll show you what that does, again, under the hood in a moment. But what that's going to do is it's going to put the large file in the DVC cache. And it's going to create two small text files. One of them is a git ignore. So if that's already created, it's going to add a line to the git ignore. And the other is a file with the same name with an additional extension of .dvc. And this is a simple text file, which is a pointer to the data file that resides within the DVC cache. And then both of these are going to be here in my Git cache and also in my file system itself. And so both of these are referring to version A. So now let's see what happens when I change the versions. So let's say I now modified my universe.txt. I added more secrets of the universe to it. And so now this is the version B of that file. But as you notice, I haven't done anything with respect to DVC or Git. So both of those caches don't have any mention of this version B yet. And so what I'm going to do now is I'm going to do DVC add to that new file with the same name. And so what's going to happen is, again, it's going to be copied into our DVC cache, and the local files that are managed by Git are going to be modified to reflect this new version. And then I'm going to do a Git commit or Git add and a Git commit. And then I'll have my Git cache include the new version of these pointer files and the Git ignore. And so we can do that again with file version C and then DVC add. So it modifies this again, and it goes back to the Git cache. So now we have all three versions in both caches. And let's say we want to revert, like let's say version C wasn't good for us and we want to go back to a different version. So how do we do that? We first want to revert the version of the pointer file. So what we're going to do is if this is in the local cache, we're going to do git checkout to the specific version that we wanted. And then, or we can do git reset as well. And that both of those options could work. And then let's say we want to revert to version A. So we're going to do that. And then the next thing that happens is the pointer files will now reflect version A. But still the file itself is in version C. So in order to sort of synchronize the DVC file, we need to run a DVC command, which is either DVC checkout, or if it's not in the local cache, we need to pull it from the remote. Okay, and then once we do that, then we take the sort of version A from here and put it inside of the file system. And so basically what would happen in this case is from the user's point of view, you sort of see magic, right? Because the file name remains the same, and then the underlying contents are changed. But what's happening sort of under the hood is exactly what I just showed. And so Alina is asking whether or not it's required to run DVC push after adding a new version of the file. So It depends. Basically, and we'll also show an example of this when we get to the hands-on part, but basically, when you do DVC add, that file is going to be put in the DVC cache. And sort of a nuance here, which I'll mention later again, but the nuance here is that DVC has a bunch of optimizations for different file systems. So it knows if your file system supports this, it will not do redundant copies of the file, but it will actually move the file into the cache and then create a link in your local system so that it looks as if there's a copy, but it will only copy it when you modify stuff. So that's pretty cool. But to answer your question, if you modify the file and you do DVC add, or if it's a pipeline, you do DVC commit, then those files will then be copied into your local cache. And so you don't need to push them unless you want to share it with someone else, or you want to delete it from your local system, which is a very reasonable use case because like even for me personally, I do a bunch of projects on my local laptop. Eventually, even if you're working with not so huge data sets, like 2 gigabytes, after like 20 versions, maybe your laptop runs out of space, or 20 versions of 20 projects. And so you'd want to push that to a storage that probably limits you less, and then you will pull it back. So hopefully that answers the question. But basically, okay, so going back to sort of the flow, basically what this means is that reproducing all of the elements of an experiment is as simple as doing git checkout plus the DVC checkout, which you can also unify. Like DVC has a bunch of like git hooks that you can use. And also I'll show you how to do that with FDS so that it's one command for both. But the idea is like with one command, you can get a copy of your entire sort of a snapshot of your project as it was when you committed it, which is pretty useful even before we're talking about pipelines. So Erwin is asking, is it possible to keep the data in the cloud when selecting it? So not to have the data local, but load the correct data version from the cloud into memory. So the answer is yes. That is an advanced use case. I'll discuss it briefly later. But usually if this is the use case that you think you need, then you should probably make sure that you're correct, because in many cases there's a simpler solution. But yes, DVC supports remote working file systems. So that's the name of what you're describing, and I'll touch upon that a bit later. So cool. We understand how DVC works at a high level, and now let's look under the hood of what's going on. But again, just to summarize, so it's kind of like Git. It uses a hash table for a cache. And in a later part of this talk, we'll show that you can push and pull parts of this cache to remote storage. Okay, so this is an example project that I have. And we'll show a more sophisticated example in the hands-on part, but I think this shows sort of the capabilities of DVC pretty straightforwardly. And so here I have like a project tree. I'm not showing hidden files. So basically I have a data folder, and under that I have a raw.csv, I have a metrics.csv, a models folder with some model that I created, and some code which runs something. In this case, it basically creates a model. And so let's say I want to track the data file with DVC. So the command I would use is DVC add data/raw.csv. And then DVC will give me this output. And so it will tell me that it has been added. And then it even tells me which command I should run with Git in order to track the changes that I just made to the project. But what actually happens under the hood? So I mentioned this sort of at a high level. So first, the first thing you're going to notice that changes is I have a new file added to this project, which is raw.csv.dvc. I also have a new gitignore file, which you can't see here. But basically, if I do cat data raw.csv.dvc and I want to see the contents of this file, what I'll see is I have an MD5 hash, okay? And basically what DVC did here is it ran a hashing algorithm over the original file, and it got this unique identifier, which is version specific. So any change to that file will mean that the hash of that file will be different to the one that DVC calculated. It also provides a bit of metadata, specifically the size of this. So you can see that because this was a demo, this is a very small, this is a size in bytes, by the way. It's a very small file, and the path of the original file, and the path is always relative to where the DVC file exists. So in this case, the DVC file is in the same folder as the CSV, so it's telling me that it's the same place, just raw.csv. The next thing that we want to look at is we would look inside the DVC cache, which is located in .dvc/cache. And what we can see there is we have this interesting folder structure where the folder name is the first two characters in that hash. And inside that folder, we have a file that has no extension. And that file name is the rest of the characters of that hash. Okay, so this is maybe the first nuanced point. So I'll repeat that. DVC calculated this hash, and then it copied that hash into the DVC cache, and it stores it in a structure where the first two letters of that hash are the file name, and the rest of the hash is the folder is the file. Sorry, the first two letters is the folder name, and the rest of the hash is the file name. Okay, and so if we were to read this file, assuming that we know that this is the type of file that it is, then we would see the same content. Okay, and then the last file that has been added is again the git ignore file. And when you peer into that, you can see that raw.csv was added there, and that makes sense because we don't want git to track that file because DVC is now tracking it. So Jack asks if it is a good practice to have the DVC file in the same directory as the file. I don't know if I have a strong opinion on that. The way that DVC operates is that it will put the .dvc file in the same folder that you ran the add for. So DVC also supports adding folders. And then if we would do DVC add data, then we would have in the root folder of the project the data.dvc that is managing the entire folder. And because I told it to add a file which exists within the data folder, it puts the .dvc file there. So that's the default behavior. I guess I don't know if there's a strong preference here, if that makes sense. Okay, cool. So hopefully this part was clear. Basically, just to sort of again review what we've seen, DVC has has this process where it can add the file to your cache. It creates a bunch of text files that are tracked by Git and point to the correct version. And so some of the nice things that you get with DVC by this point, like some of the superpowers that you've already gained here, is that DVC has built-in optimizations for large folders. So it natively supports workflows around, for example, unstructured data sets. It also does file level deduplication, which is like Git. And that means that if you have a folder of 1,000 images and you change only one image, then DVC is not going to duplicate all the 1,000 images. It's going to duplicate just the one that has been changed in the cache. But on the other hand, if you have a table, which is 5 gigabytes, and you change one row of that table, that entire table will be duplicated because it's the same file, okay? And finally, you have a local cache, which is very useful for quick checkout. So it means that if you have a data version that you've accessed in the past, they will be saved nearby and make it easy for you and fast to sort of check them out without needing to download them from anywhere. And this does mean that you need to be aware of your cache and garbage collected as needed. Otherwise, it might grow very, very, very quickly. And so Yang is asking if it is a better practice to split data into smaller files. And the short answer is yes, if your workflow supports that. So I think the technical term here is sharding. And I think that the guys at DVC are possibly working on integrating that as sort of a first-class use case. But currently, yes, if you can split, if you're working with tabular data and you can split that data in a way that makes sense, then that would be very useful. Whereas for unstructured data, again, like image data sets and stuff like that, then DVC just works out of the box. You could just do DVC add data set, and if that's a folder with the images, and it would work. Cool, so we have a few superpowers. I might just pick up the pace a bit so we have enough time to go over everything. So we have a few superpowers gained. One of them is time travel. So we have now a time machine that lets us, that doesn't only encompass one part of our project, just the code, but actually the entire context. So something bad happens, we can easily revert to the project before the issue is introduced. And this will also speed up debugging. So it's also useful for disaster recovery. But then the next question might be, okay, but I have a team of 4 people, and I want to take care of sort of the flows that are involved when you have more than one person working on a project. So how can we use our newly gained powers to improve the team-oriented activities that sort of we'd like to happen? And so we'll talk about task splitting a bit later, but starting with onboarding and handoffs, the next logical step is remotes. So if Git remotes is what enables a new developer joining a software team to get started with the code base, DVC remotes enable sort of the same experience for a new data scientist. And so DVC remotes are similar to Git remotes. They will let you define, DVC lets you define multiple remotes, which is useful for some use cases. It's important to note that due to the differences in this workflow, the remotes are separate from the Git remote used, except for the case of DAGSub, where they sort of exist alongside each other. And this is mostly an advantage because it means you aren't tied to your Git provider. So you can connect the data storage to any of the cloud providers or whichever storage solution you use. But it does mean that you need to pay attention to which files are pushed to Git and which files are pushed to your DVC remote. Now, once you define a DVC remote, you can push parts of the hash table or the cache to that remote. And all of this is done under the hood with the libraries of these object storages. So that means that you add minimal overhead on top of these very efficient libraries when you use them. And that also means that DVC doesn't need dedicated servers, and it's built to handle really large files and folders like data sets. And also there is very broad support for different types of remotes. So how does the remote workflow look like? You basically have one command, which is similar to the git remote add action that you do, with the difference that you need to also manage authentication. So authentication varies by the type of remote that you're using, but in the simplest case, which is sort of HTTP or the DAGSub remote, you basically add 3 lines of code to your project, and then you are good to go. And then in order to push data, you just do DVC push -r origin, or the name of the remote. So in this case, I called my remote origin, and you're off to the races. And so under the hood, DVC will review the hashes of the files in the remote and compare them to what you have in your local cache. It will locate the relevant files that sort of comply with 2 things. First, they need to be in your current workspace. So files that aren't in the workspace are not going to be pushed by default, and sort of are missing from the remote hash table. And then it's going to push them and only them to the remote. So what that means is that if you push after every commit, your local and remote hash tables should be the same. And that makes them available for the rest of your team. So the basic workflow is basically sharing data and train models is super easy, and you just do it with a DVC push and then a DVC pull. And you can also recycle preprocessed data, which is a nice basic use case. So if I ran a preprocessing step that took 3 hours, and I don't want you to run it as well, I can push the result to our DVC storage. You can pull it, and it's as if you ran it yourself. So that's pretty convenient, especially if you have a setup where you have maybe a training server, which is stronger than your local computer, but then you do want to do some post-processing or visualization locally. So both of these are covered basically by the flow of DVC push and DVC pull, but there are also some more advanced use cases. So one of those use cases is data and model registries. And I mentioned this briefly before, but this is a use case where if you have so the idea of this use case is basically that you have an entire repository which is dedicated to tracking a single type of artifact. So you either have a repository that has like data sets with an updating version, or maybe you push your trained models to another model repository and then you update those versions as well. And so that can then be consumed by multiple teams or projects. So if you have this complicated pipelines and multiple teams are responsible for different parts, and this also is starting starting to address the task splitting aspect, then you can have one person working on this reprocessing step and generating new versions and treating it as if it was a package. And then other teams can actually use DVC import and then import that data set or model into their system. And so that is a very useful use case for many teams. And I'll share later a blog post that we wrote about this if you're interested in diving deeper. And then also, we talked about remote working file systems, or someone here asked, and Erwin asked about this. So DVC can also enable you to extend your local workspace. And this can be relevant when you're working with, for example, huge files that don't fit locally. We won't go into the finer details here, since this is a more advanced use case, but the gist of it is that you can define a remote with a relative path. And so that such that it exists on your cloud storage, and a version of it, or not a version, but a copy of this exists for each participant. So basically, you're extending your local working file system to your cloud, and this will let you add files to DVC directly from cloud to cloud without it touching your local system. And this is especially useful if you're doing remote processing, or if you want to read, process data by batches. And I don't think I put the link in this talk, but feel free to reach out to me afterwards. I also have an example project with this, if this is relevant for you guys. Okay, so we talked about, let's see if there were any questions. Philip says, how can you run a recursive command using DVC? Okay, so basically the answer to that question is separated into two. You can first do DVC add -r, which is recursive. And what that will do is if you input a folder with that, it will basically add the entire contents of the folder to DVC file by file. So it doesn't use the optimization that DVC has for directories. So this is not recommended unless you're sure that this is what you need. And then the git add -a experience, and again, combining that with DVC is something I'll show with fast data science, but that's something that we developed where it's open source as well. But the idea is that we identify files that you might want to put in DVC, and those that might want to put in Git, and sort of ask you where you want to put each. So that's one thing. And yeah, so there's also, okay, so I see someone is also answering for this. Awesome. So let's continue. So you might notice at this point that reproducibility isn't perfectly addressed by saving the versions of artifacts. So you've made big strides towards it, but we aren't there just yet. And so at this point, you might argue something like, what about managing configurations? What about the packages and the environments that I'm using? They aren't covered yet too. But in that case, I would argue that all of those might be maintained as text files or artifacts. And they would be versioned with either Git or DVC. So I'm not talking about that caveat. The caveat that I'm talking about is, and let's look at a problem example. So going to basic math, because a good data talk has to have a bit of math in it, right? So let's say we have two processing steps in our project, and each of them receives some input and performs a very basic mathematical function on it. Now, if we're running function 1, then function 2, we're going to get x plus 1 squared. But if we run function 2 and then function 1, we're going to get x squared plus 1. And in most cases, those results are not equal. So first, check on math. And that's sort of some sort of proof in theory that reproducibility might be more challenging than just managing the artifacts. But why should I care about this in real life? And the answer to that is, in my opinion, that many things can go wrong, and ensuring reproducibility means it's easier to pinpoint the issues. So you can look at where your sort of pipeline is breaking apart and focus there instead of having to go over everything to find issues. It also shortens the time to onboarding, handoff, and all of those other sort of activities by orders of magnitude, because you don't need to sort of start from scratch and assume that things are working, but you can actually see them work and sort of apply changes and then run only those changes, which is pretty awesome. And then finally, you can be sure that you are comparing apples to apples, which I think every data scientist realizes how important that is. When you think the two models are sort of, you just change a few parameters, but then you realize that you trained them on completely different data sets, and that's why sort of the performance is completely different. So what I would like you to take away from this is that you should track your pipeline. And the best way to do that is with DAGs. So we're obviously biased, but I hope everyone here likes DAGs as well. And so basically, DAGs let you define dependencies, outputs, and commands for the different sort of machine learning pipeline stages that you have. They are basically necessary for ensuring reproducibility. So even if you don't define a DAG officially, the order of by which things run in your pipeline is an integral part of making sure you get the same results. And this shouldn't be scary. So the simplest way to define a DAG is just a YAML file, and I'll show an example of that. There are many ways to define a DAG, but it's really, it can be human readable, it can be very friendly, and DVC lets you define them. And then you also get a bonus of versioning all the dependencies and outputs, which is pretty awesome. So basically, there are multiple ways to define a DAG stage in DVC. One of them is to use the DVC run command, which receives receives sort of the inputs or the dependencies with the -d flag. So you can see in my case, I have the data raw CSV, and also the code is a dependency for this stage. The output is the model. And then I also have an output, which is the metric. And I gave the stage a name, that's the -n flag. And finally, I give it the command that it should run. And we can also define the stage without running it. So in this case, if I just use this command like this, DVC will define that stage and run the command as well. Sorry. But we can also use the --, so no exec flag when we do this. And then DVC will only define the stage in the YAML without running it. And so once we run this command, what we're going to get is two new files. So the dvc.yaml, which is basically superhuman readable. It has stages, the name of the stage, the command that's being run, the dependencies, which is like a list, the output, which is also a list. And in this case, we also have metrics, which is just a special type of output. And so what we're using here is cache false, which basically means that by default, DVC assumes that every output of a stage is something that DVC should track. So if you want it not to track a file, or in other words, to have Git track it, then you just need to make sure that it has cache false within the YAML. And then the other thing that we're going to see is the dvc.lock file. And so what we're going to see in there is basically a similar structure, but in addition, each of these files has the MD5, so the unique hash, and a bit more metadata. So the size of the file, and that's sort of what DVC uses to make sure which files have changed. So with DAGs, we can visualize this, and this is just a bit more intuitive to explain what's going on here. So you can see that basically this command is sort of the essence of the stage. And if you actually expand this, I'll show this later, you can see that command within this DAG. You can see that the data is sort of the input here. And then you have the code, which is running here, which is sort of an input as well. The metrics are here. And finally, the output model is here as well. So you can sort of see the equivalent between the text file and the visualization, which is obviously more convenient, but it's basically the same information. Cool. So we're almost at the end and getting to the hands-on part. So bonuses from DVC DAGs, in addition to sort of the reproducibility, you get the added benefits that execution might be painful in many cases. And so you don't want to run what you haven't changed. And so, for example, training a model, in some cases, pre-processing might be very compute or time intensive. And that might, and this is a trade-off. So it depends on the price you pay for this processing versus the price you pay for storage. But in cases where the processing costs more than the storage, then you can basically DVC conversion the outputs and then check what has changed and only run the things that are necessary to reproduce the end result. And finally, you can automate this entire process. You can define very complex pipelines and then just use DVC repro to rerun the entire thing, which is pretty awesome. And so to conclude all of this part, sorry, did someone say something? Okay, so to conclude this part, basically reproducing a result with git checkout sort of gets you the files, and then you can verify that it runs from start to finish with DVC repro, which again is super useful, especially in sort of team use cases. Okay, so pros and cons. I see that there's a question. I'll address it in a moment. I'll just finish with the presentation so we can get to the hands-on part. So pros and cons, why and when to use DVC. First, we're strong believers, or I'm a strong believer, that you shouldn't use tools for the sake of tools. You want to know which problem you're trying to solve, and having a hammer shouldn't make everything a nail. And then DVC is really great for unstructured data. But if you're using Spark, which is just a code name for huge structured data, then you probably don't want to version the raw data with DVC. And the use cases that we've seen with DVC in those cases are, for example, you version the query outputs that you're actually going to train the model on for posterity, but not the entire database. And if I'm using maybe a giant standardized data set that is never changing, for example, ImageNet, and this is with the asterisk that ImageNet has changed in the past, so this is not always true, but if you're using a standardized data set, then it might make more sense to version only the models and the process data and not the not the end result. And then finally, DVC pipelines are awesome, but they currently don't natively support distributed workflows. So if that is sort of your core use case, you might want to use a dedicated solution like Kubeflow pipelines or Dagster or one of those tools. It is very useful for sort of storing the information of what the pipeline looks like in the same place as your code. But again, if your core workflow is around distributed computing, then you might want to use something else for the pipelining part. So you might still want to use, we know a lot of users that are using Kubeflow pipelines and then DVC to version the results and the inputs. But sort of that is maybe another proposed use case. So there was another question. Yeah. So this is a good question for me because basically, Matit basically asks whether or not there is a diffing solution for DVC tracked file because the Git is sort of Git is only tracking the pointer to the file. So how do I diff DVC files? And so DVC in its native form doesn't really support that sort of as is, but that's one of the added benefits of using DAGSA, which again, if you're going to follow along the hands-on session, then you're going to sign up. It's completely free. And if diffing data is important to you, then that's part of the capabilities that the platform provides on top of DVC. Same as GitHub on top of Git, basically. We'll show also the capabilities of diffing that DVC provides, which is basically telling you what has changed when, which is also useful. But if you actually want to look at two versions of images, then you're going to use DAGSA or something on top of that. And so the other two questions are, is it possible to version the data when it is in the cloud, for instance, in S3? So the remote working file system is one solution for that. If DVC has not already merged this in, it's going to be merged pretty soon, enabling you to just add the data the first time from the cloud as well. So you don't have to copy it locally in order to add it. But I'm not sure that that's implemented right now. And then the next step is, the next question from Bayang is recommendation for large tabular data. So there are tools that are built especially for versioning large tabular data. The examples of that are open source are Delta Lake, which is Databricks project. You have Dolt, you have Terminus DB, which I think are all sort of the main players. And I think the popularity of those are like I said, so Delta Lake, Dolt, and Terminus, but I might be mistaken. And the caveat there is if you want to use those, you need to migrate the schema of your database to one that they support. So that's not always something that organizations are willing to do. And I think that one point here is so I'm going to give a talk next month about sort of how to choose which tools to use. I think that one point to notice here is that maybe you don't need to version your raw data. So if you have a raw data set that is never going to change, or it's only add only, maybe you just want to version the subset of that data that you're actually training your models in experiments. And so you can feel free to reach out to me after the call, after the talk, and I'd be happy to help sort of after I understand more of your the details of your use case. And the final question before I'll move on is, why not store and track everything in track the preprocessed results that will be used as input for the model directly in a database as a timestamp version, and use DVC instead? So you can basically store things in a database. Like a hash table is a form of data structure, right? So it all depends on what you want out of the box. Basically, the people, the awesome team behind DVC built a lot of sort of optimizations and capabilities into the system, such as the native support for cloud storages and object storages that you might want to use, such as optimized protocols for pushing and pulling and deduplicating data and stuff like that. So it is sort of arguably more convenient. But yeah, rolling your own is always an option. I personally don't recommend it, but there are some use cases where it makes sense. So moving forward, one question that still might remain is, I need a separate tool for data versioning, but why? And this is one of the common complaints that we've heard, sort of like, why do I need to learn a whole separate tool and I can't just use DVC in addition, and I need to use it in addition to using Git in order to get the desired outcome of versioning everything, and sort of having a more reproducible project. And so some of the issues, so this leads to a bunch of things that DVC is not focused on. And that makes sense because after all, it's more of sort of an infrastructure oriented project in the same way that Git is. And so you might want a higher level API to deal with things like remembering the order of commands that you need to use in order to do something, or deciding if a given file should be tracked by Git or DVC. And sort of DVC is also very agnostic, which is great for flexibility, but it's suboptimal for certain automations and ease of use. And so that is exactly why we created FDS, or Fast Data Science. Let me play this video as well. The idea is it combines Git and DVC so that you only need to type one command at a time. It also has a ton of automations, like a wizard for adding files that helps you decide whether a file should go, where a file should go. And you can even do stuff like FDS save, which shortens everything, like the add, the commit, and the push, and just does it for you. And so you can, this should make your life easier, especially if you're working with DVC sort of intensively. And you can download it now or start on GitHub. That would be appreciated. Cool. So I'll stop sharing for a moment to share my Google Colab. Oh, and by the way, actually, before that, where's the file that I'm looking for? Sorry. Yeah. So you can use this QR code. Let me make sure that I'm sharing the screen. You can use this QR code if you like to go to the URL. I'll send it also in a moment in the channel, so this chat rather. So I'm going to work with this. I'm going to do a bit of live coding, which is always fun. Oh, it says that sharing is stopped. Sorry. Okay, so you can all go into this, and I'll start sharing my screen. Okay. So let me know if this, if you can see this properly. Someone just like do the thing with the thumb so I know it works. Yes. Okay. Cool. So and I'll also take a sip of water. So if you have any questions, now would be a good time, and we'll dive into the nitty-gritty. Awesome. So everyone understood everything. So we are going to go over a bunch of things. By the way, I'm going to start by installing all of these packages, just because it's going to take a few minutes, and explain. So basically, we're going to do a live coding session for DVC and a bit of FDS. What we're going to do here is we're going to build a project from scratch. We're going to use DAGSA because, again, it's the easiest way to set up a remote, so we don't have to mess around with like cloud settings and stuff like that. And so you can follow along. In order to do that, and you can do this while everything is installing for you, you should sign up for an account on DAGSub and create a repository. So these links will lead you to the exact place you should go to. So I already have an account, so I'm just going to click the create a repository. And it's going to lead me to this form. And so I'm going to call my project Who Moved My Data Live. I'll add sort of a description here, live coding for PyData Global. So leave it like this. And I'm not going to change anything else. So it's public. I didn't touch anything aside from that. And I'll just do create repository. Oh, sorry, and I didn't delete my old repository that I practiced with, so I'll do that first. Let me go to my profile. So nice. This is what you get for live coding. It's going to be fun. Don't worry. Who moved my data live? Okay, so I practiced this before. So let's remove this. So I start from scratch. Okay, so same thing. Who moved my data? Thank God the browser remembers. So live coding for my data global 2021. Capitalize it. Cool. And so now we have this empty project. Not super interesting. A bunch of commands on how to set things up. And so I coded that into the notebook, so we could just leave it as is for now and go back to our notebook. If you're following along, I hope that by this point you have finished installing stuff and you don't need to restart your session, even though it will tell you you do. It will actually might cause problems if you restart, so just leave it as is. And then let's make sure that the versions have been installed so we can see this. By the way, there's no files here, so just the sample stuff that Colab comes with. And so we're doing a bunch of imports for the logistics, so we can sort of download data later and manage the passwords and stuff like that. So let's do that. And assuming you signed up, the next step is going to be writing in your DAGSub username, the repo name, and your email. And so now you have my email. You can send me hello. And let's run these cells just so we have that. And this is basically putting them into sort of environment variables that we're going to use later. And then I'm going to run this step, which will require my token. So you can get your token by going to the settings panel and then going to tokens. And you can copy your default token. That will work. You can also put in your password, but I always recommend working with tokens where possible. And now we have that as well. So the next step, yeah, sure. So Lavanya is asking about if you can do this after the session. This is going to remain accessible to everyone forever, basically. So you can do it whenever you want, and you can just follow along with me if you prefer. So basically, now I'm going to create the file structure. And what I'm going to do here is just making a directory called DVC showcase. It has an internal directory called data, and that is empty. And I'm going to do one last setup thing, which is defining my user email and name for Git, because Colab needs it in order to push and pull stuff. And now we're going to init git and DVC. So this is a command I didn't cover because it's pretty straightforward, but we'll see what happens. And it's going to tell me that it initialized an empty Git repository and initialized an empty DVC repository. And now if I run Git and DVC status, we're going to see that Git has a bunch of new files added. And these are all within the .dvc folder. So those are basically sort of logistic files that DVC has created. And then for DVC, it's telling us there are no data or pipelines tracked in this project yet. And so if we want to look at what's being git ignored within the .dvc file, because I see that I've added a .git ignore file here, I can see that it's ignoring a local configuration file, which makes sense because that's usually where the passwords are stored. It's ignoring temp, and it's ignoring a cache. And this cache is where all the large files are going to be tracked. So it's good that Git is ignoring that. Cool. So now we are going to create a Git version with all of these changes, just so we're set to go. And that's it. Let's dive into things. So we want to download a version of data. So what I'm doing is I'm using wget, and I'm downloading a data set, or maybe let me take a step back and explain what we're doing here from a data science perspective. So this is going to be a project where we're taking data that we extracted from the Stack Exchange API, where there are a ton of questions that people have asked. And I'll show you when we push this to the DAGSEP, I'll show you sort of some of the data so you understand what I'm talking about, but questions that people have asked on Stack Exchange. And we are going to build a model that predicts whether or not a question relates to machine learning, and then it can provide the machine learning tag suggestion to the user. And sort of the logic behind such a product would be that a question is more likely to be answered if you add tags to it. And so this can help the user improve their chances of getting their question answered. And so we're now downloading a version of this data, and we want to track it with DVC. So you can see that my data folder now has a raw.csv file, and let's do DVC add raw.csv. So we're going to see a bunch of things that DVC is telling me that it's doing, but basically it's adding this file. It's doing it very quickly because it's relatively small, just like 75 megabytes, but definitely something you don't want to push into Git. And then it even tells me in the end, it says like it's added, and it tells me that if you want to track these changes, you need to run this command, which is very nice of DVC. But let's review the things that we discussed earlier. So now we have a raw.csv.dvc that has been created. And if we run this, we're going to see exactly what we talked about earlier. So we have this MD5. We have its size, which is 75 megabytes. So it's a bit less than 75 megabytes. And then we have the path to it, which is exactly like we saw before. And if I look at the DVC cache, I can see the, again, the same structure that I discussed. So the first two letters are the folder, and the rest of the hash is the file. And that's awesome. And if I look at the git ignore, I can see that the raw CSV is there. Okay, cool. So we have tracked our file with DVC, but this is not yet tracked by Git. So if I go and I do, let's say git status and DVC status as well, let's run that. And we'll see that Git is saying that data is still there is a file within data that is not tracked. And those files are actually the raw.csv.dvc and the .git ignore, because this is git ignored as well. So Irina, yes, I'll share all of the materials on Slack afterwards. And you can continue following along. Like, I think this is, you can go over, I shared the link to the notebook, and you can see what I'm doing in real time. So feel free to sort of jump in and sort of work with us. So now let's, but DVC, by the way, says that the data and pipelines are up to date, because from DVC's perspective, it compares the raw.csv.dvc with what it has in the cache. And it says, okay, I'm up to date. No worries. We're all good. So, so let's commit this to Git. And I named the commit adding raw data to DVC tracking. And now let's change our data. So I'm actually doing this the reverse of what happened in real life. So I'm now downloading something that from the name of the branch you might already know, sort of the spoiler is that it's not good data. And what actually happened when we did this project originally was that the query that we used for Stack Exchange wasn't sorted by date. So we just got a random assortment of questions. Some of them were like ancient and some of them were super new. And obviously when you train a model for real life use cases, you probably want the most current data. And so we got this data version, which is also smaller. And you can see this one is 63 megabytes. The one before was, I think, a bit larger. Yeah, so 72 megabytes. So it's also a different size. And now that I downloaded it, let's track it. So now there are two ways to track it. One is to do DVC add data/raw.csv, which is what we're going to do. But you can also do DVC commit, and then as an input, give it a DVC stage. So that works both for adding, so I would do raw.csv.dvc, but also for pipelines. And I'll discuss that maybe a bit later. So let's run this. And DVC is basically going to do exactly the same thing that it did before. And so it is now going to tell us I don't need to now recommit some of the files, but for example, the git ignore is still ignoring the same file, but the data.raw.csv.dvc has changed. And so let's look inside. And what we can see is that the hash here and the size are different from before. So just to remind you, before it started with a 14, and now the hash is starting with a 70. And when we look inside the cache, we're actually going to see that now there's another sort of entry in our hash table. One of them is sort of the old one, and this is the new one. And when we look at the project, so you can see this also here, it's basically the same. Like it's sort of like magic, right? The raw.csv has been changed, but we have both versions in our cache. So if I want to go back to that old version, I could just do git reset -- hard head because I didn't commit anything to git yet. And then when I look inside the .dvc file, I can see that I reverted to the old version. But notice that what's happening now, if I do git status and dvc status, git is going to say everything is okay, like there's nothing changed, right? Because I reset to the last commit. But dvc is going to say, wait, you reverted the git files, but not the DVC files. So it's going to tell me that there's a changed output for the raw.csv.dvc file, which is data/raw.csv, and that makes total sense. So in order to sort of synchronize the project, I'm going to do DVC checkout, and now DVC is swapping the files. So I have the original file that I want, and if I do status again, it's going to tell me that life is good. Cool. So we have our first version tracked. I know you're all excited. Let's push this to remote. So now we're going to run all of the commands that I showed earlier in the slides to set up the remote. This one is to set up git. This one is to set up DVC. And notice that we're using our placeholders. So if you did the first part of like putting in the name of your user and your project, it's going to be set up for you out of the box. And then we're doing the sort of authentication setup, which is basically going to be, we're using the -- local flag, which means DVC is going to make all of these modifications to the dvc/config.local, which is not going to push to DVC. So you can't take my password. And now if we're looking inside the config file, we're going to see that there's sort of a remote origin defined, which is the name I called my DVC remote. And that URL is dagzip.com/d/removemydata_live.dvc. So similar to the remote you'd have on GitHub for Git, which ends with a .git, here it's ending with a .dvc. So now let's do git status. And it's going to tell us that DVC config has changed. By the way, DVC status is not changing anything, right? Because we haven't modified any of the DVC track files. So data and pipelines are up to date. And now let's commit this to Git. So we're adding this to DVC remote. And let's do push. And a note here is because this is Google Colab, they have an issue with authentication. So you can't just push to the origin without adding the token into the URL. It's kind of annoying, but it's sort of a necessary evil. So you just need to do this and it will work. You can also copy this for the future and just modify the URLs. The URL for your project, if you're using something which is not within this realm. And so what DVC is doing now is it basically pushed the 72 megabyte file, which is, and it only pushes that. Even though my local workspace has another file, because there are no git commits that refer to that file, that is not being pushed, okay? That's an important note to take. And now I'm going to use this nifty IPython display function to show you how my DAGZA project looks like at the moment. So you can see, you can see basically this file structure. That is basically the file structure that you can also see here within the data. I'm also showing the hidden files, which are .dvc and .dvc ignore. And you can see this very basic pipeline, which is just like adding a raw.csv file. But the nice thing is I can actually scroll to the data file itself. So this is a file that is not tracked by Git, it is tracked by DVC. You can see this as part of the UI. So if you wanted to see earlier what's the data, like what are the samples that I'm actually looking at? Sorry, this is because it's an iframe. You can actually see that each row here is a question on Stack Exchange. So you can see the name, accepting, null, hypothesis, giving specificity. There's body, there's a few tags. So that's pretty, it's pretty useful. And then there's a bunch of metadata on this data as well. But let's get back to things, okay? So we now have our first version tracked, and let's build a pipeline. Okay, I see that Erwin has an issue with IPython is not defined. Make sure that you ran the import cell at the beginning where we're doing import IPython here. So that should work after that. And if not, then reach out to me afterwards and I'll try to debug it with you. But this sort of runs end to end. So if you're running each step one after the other and you created the project on DAGS Hub, then it should just work for you. Okay, so where were we? We pushed the first version. Now let's start with running stuff. So we'll need to download a script, which I prepared in advance. So we're not doing that level of live coding. I ran this, so now our project is going to have a preprocess.py file. I can open that and sort of, you can see it's pretty straightforward. I'm doing a bunch of like house cleaning, so changing the format of the date, creating a sort of an output or label basically column using the sort of a machine learning tag here. So I'm checking whether or not the tag contains machine learning, and then I'm labeling this as true for the machine learning tag. And I'm also making sure to remove the tag so it doesn't use the input to predict the sort of the output and doesn't cheat. And that's basically it. You can dive into this later if you want. But yeah, this is, I'll move this, I'll close this. So let's go back to where I was. So now I'm going to run the similar command to what you saw before. So the dependencies are the raw data, the code that sort of runs the preprocessing. Then the output is going to be two files. One is train and one is test data. And then I'm going to call this step preprocessing, and I'm going to run the command python3 preprocess.py, which does all of this magic. So let's run this. And this is a relatively fast step. So let's see what happens in our file structure. Basically, okay, awesome. So it's done. So basically now let's refresh this. You can see that our data file or data folder also has a test.csv and a train.csv. Notice that it does not have a raw.csv, or it doesn't have like a test.csv.dvc because it is managed as part of the pipeline. And then we have a dvc.lock and a dvc.yaml. So let's look inside those. The dvc YAML is basically what we saw, similar to what we saw before. It has the name of the stage, it has the command that we're going to run, and it has the dependencies and outputs. Do you use the sysargs within your Python modules so that DVC can run the pipeline? I'm not sure I understand the question, but DVC is basically agnostic to what you run and how you run it. So the script is in charge of receiving parameters and processing the data or training the model and then outputting the outputs. And what DVC checks is that the inputs that you define here exist before the model is run, and that the outputs that you define exist after the stage is run. And so it's your responsibility. You can do it however you want, which is, again, very flexible, but sometimes it means that you need to do a bit of work up front to get everything ready to go. And so back to what we've created, let's look at the dvc.lock. Again, very similar structure to the DVC YAML, but we also have our MD5s. We also have our MD5s and the sizes of our files here. And this is the same for the outputs. So the test.csv, this is basically equivalent to what we saw before in the .csv.dvc file, but we have this also for the outputs, and this is what DVC is going to use to manage these versions. So now let's do git status and the DVC status. I'll take this opportunity to take a sip of water. Okay, so what we can see here is that we have a modified .gitignore file, which makes sense because what we added to it are the outputs of this file. We have a DVC lock and DVC YAML that were added. We have the preprocess.py, which we downloaded downloaded before. Yeah, okay, I see now with Matit's, exactly. So you can hard code it, which I did for the sake of simplicity. It is not a good idea in the longer run. In the longer run, what we recommend to do is to have a parameters.yaml file and then have the DVC script read those parameters and use them. That is a more sort of robust way to manage your project and configuration in a sane way without having someone have to read your entire code base. But because this is a very simple project and a demo, I thought it would be easier than adding a bunch of dependencies. Okay, so now we're going to do a bunch of commands, which are basically the data. By the way, the DVC status is that everything is up to date. Because again, DVC compares the files that it sees in your workspace with the DVC lock or the .dvc files, and it sees that they all correspond well to each other. And so it's not complaining about anything. And so we only need to add and commit our changes, but not to DVC add or commit anything. And now let's do that, and then also let's push this to our remote. So this is basically the same commands that I ran before. It's going to take a few more seconds because it's a bit larger now that I process the data. But that's it basically. So you can see that it basically performs the same action as before. And let's do the same thing and look what we have at DAX Hub. So we have the same project, but it's now, sorry, I don't know, it scrolls to the bottom. It has a bit more files. So you can see the preprocess.py here, and then the data folder is also sort of including the test and train data. But also our pipeline, if we remember from earlier, this should look a bit similar to what you saw in the presentation. So you can see that I have my raw CSV and the preprocessed code that are going into the preprocessed step. By the way, if I expand this, you can see the command that I was actually running. And then the outputs are the test and the train CSV, and that's awesome. So we are good to go. So let's go to the next step, and let's create a training script and a training stage for our pipeline. So we're going to do this in a different way than what we did before. But first and foremost, let's download our training script. So if I refresh this, we now have a train.py. And this is going to use both the train set and the test set, and it's going to do all in one. So it's going to train the model and evaluate it. And the output is going to be the model plus a test metric .csv, which is going to, it's going to be both test and train metrics in one CSV, and it's going to tell us sort of how the model performed. And this time we're going to create this step in a different way. So I created this, I wrote this code down, and I'll double click it just so it preserves the indent. And let's copy this and put this in our dvc.yaml. So you can also edit the dvc YAML directly. And I'll just paste this here. And the thing you should notice here is the indent. So make sure that it's not all to the left or something like that. The indent is important. So you have the name of the stage, and then it's indented once. You have the command, the dependencies, a list, the outputs, a list. And in this case, our parameters, which are an output, are tracked by Git, not DVC. So that's why they have cache false. And then we have metrics, which have special treatment. And those metrics are also tracked by Git. So they also have cache false. So let's save this. Okay, it's already saved. And we can close this, and let's go back to where I was in my process. So we updated this, and if I look at my DVC YAML, I now will see the updates, which is good. But if I go to Git status and DVC status, DVC is now, so Git is going to complain that the DVC YAML has been modified, and I added the train.py, but DVC is also complaining. Why? Because it is looking for these outputs that I defined in my process, in my DVC YAML, and it's not finding them. And it's also looking at the train and test.csv, and it sees that it doesn't have hashes for them, because in my DVC lock file, basically, I don't have the dependencies or the outputs for the next stage. So DVC, if it lacks the hashes in the DVC lock, it says that something has changed. So now if we want to run this, we can do DVC repro, and DVC is going to see that the preprocessing step has already been run. So it's going to tell me stage preprocessing didn't change, I'm skipping this. Also the raw.csv.dvc stage hasn't changed, so I'm skipping this. And now it's going to train the model. Let's wait a bit, but it's basically using TF-IDF and then a random forest classifier. So a very basic model. And I think the nice thing is I'm probably going to make it on time, which is awesome. But if you have any questions so far, this would be a good time while the model is training. Anything else that you feel I didn't cover? Awesome. So as a side note, I will be available both on Slack and the Gather account afterwards. So if you have any questions, you feel free to reach out to me, and I'll be happy to help. So now it's saving the TF-IDF, which we fitted, and it's now training the model. And this shouldn't take too long. We can go back to the folder structure, by the way. So by the way, to log the metrics and the parameters, we're using a library which we created, which is super simple. It's called DagSub. You can do pip install DagSub, again, open source. And what it does is basically logs the metrics and the parameters to files. So these are human readable. You can open them, check them out yourself. And we like that because it makes it easier to share. You don't need context in order to understand what's going on. I'll show you the contents in a moment. So Manuel is asking, why is the Py script itself a dependency? And so the way you need to think about this is, when do we want DVC to run this stage again? And so obviously, if the data has changed, we want the step to rerun again. But also if we change the code, so maybe you change the code, you're using a different model, then you want DVC to run that training step again, because the results are going to be different. And so the way we think about dependencies is we want to define the things that for this stage, if they have changed, we want to rerun that stage. Okay, so it's finished running, perfect timing. And yeah, I'll show, Ilya, I'll show the FDS in just a moment, but the answer is yes. So the parameters, just so you can see what we've created, look like this. It's just a list of parameters, both for the TF-IDF and the model, as well as the metrics are also a very simple table that you can see. So the name, the value, and when these metrics were logged. And again, this is a very simple model, so everything here is simple, but you can log more complex metrics as well. Cool. So what did we get out of all of this thing? So now that it's run, let's go here. So basically, let's look at the Git status and DVC status that we have. Basically, now DVC is saying data and pipelines are up to date. Yay, it's done, successful. And Git is saying that DVC lock and YAML have changed, which makes sense because I modified the DVC YAML manually. And then the lock was changed after the DVC repro. And then Git ignore, we have a model now in it, and then metrics, parameters, and the train, which we added. But if you have noticed, and Ilya has noticed because he asked about this, we ran a ton of duplicate commands throughout this tutorial. So what if you wanted to unify everything? FDS provides that. So I pre-installed FDS in the beginning, and we can actually now do FDS status. And it will basically do the same thing as the command before. It prints it in a neater way, so it's clear to see what DVC is saying and what Git is saying as opposed to here. And it is also, just to make a point of how useful this is, you can commit all the changes and push them to your remote with one command for both DVC and Git. And you can do this by running FDS commit and then FDS push. But if we want to make it even shorter, we can use FDS save. And FDS save is basically a short for add everything, commit everything, and push everything to the remote. And that is very convenient. So just to clarify what I'm using here, we have FDS save. And then this flag means this is the Git remote. And the reason I need to specify it specifically is because of the collab issue. So if you're working locally, you don't need to do this apart. If you set up your Git remote, FDS knows. And then also, we are going to add a message, a save message. So in this case, adding the training step. And this FDS add is actually interactive. So if I go back to what I said before, it is now going to look at the different files, and it's going to ask me what I want to do with them. So it sees that I have a data folder here with 220 megabytes. And it's asking me, should I add the entire folder to DVC? But I know that I don't need to because it has been added, like the contents have been added. So I'm just going to type in S, which is going to tell it to step into that, and then it's going to realize that itself. And that's it. So you can now see that it added everything successfully, both to Git and DVC. It committed everything to Git, and now it's pushing everything both to Git and to DVC. And it tells me in the end, I successfully saved your current workspace. And let's see that make sure that it works. So let's see how my updated project looks like. And so now what we see automatically is the train.py has been added, as well as the metrics.csv and the params. And look at this super nice pipeline that we have. Again, the pre-processing step has basically not changed, but the test CSV, train.csv, and train.py are now going into the training step. And the outputs of those are in the outputs folder. So I'll show you those in the middle in a moment. You can actually go to them from the pipeline itself. So it now opens it in a new window, but you can see that I saved the model and the TF-IDF tokenizer. And so that's super nice. And you can even see the metrics for your model within this pipeline as well. So that's also pretty cool. And also, because we're using this very standard format for metrics and parameters, you can also see we have this experiments tab, which is, sorry, let's let it load. We have this experiments tab in every project. You can actually see this experiment logged as part of a table. So you can see the different metrics and parameters. You can actually play with this, so modify the metrics and parameters that you have, and then dive into a specific experiment and see how it performs. And so that's also pretty useful. And that is it. So I have 4 minutes. I'm pretty proud of myself for making it in time. Thank you very much for sort of joining along for this journey with me. And if you want any further reading, so the first link here is for data registries using DVC. It's really nice. One of our team members wrote it, and it's like not necessarily tied to DAGZUB. It's really awesome. The other one is an example of automating, sort of creating continuous training with Jenkins in DAGZUB using DVC. And then the last one is one explaining FDS in more detail. And again, please follow me on Twitter or LinkedIn and join our Discord community. You have links to all of those on the notebook as well. Let's see if there are any other questions. So, so Matit asks about minus the option to DVC run, extremely prone to human errors. The short answer is probably we recommend editing the DVC YAML directly as opposed to doing DVC run. I agree with you. It's prone to errors. The way I would do this before sort of the DVC YAML was easy to use as it is today was I would write this in like, I would write the commands in scripts, make sure in like a text file, make sure that everything is good, and then only then copy this and run this into the command line. So definitely recommend, I prefer to edit the DVC YAML instead. Martine asks if there's a way to self-host DAGZUB. Please feel free to reach, the answer is yes, feel free to reach out to me and we can discuss this. So Jamie is asking about the lock file. So I indeed covered this. You can see the contents here above, but basically what it has is the same as DVC YAML, but for each file, it tells you what is the unique version of that file in the current workspace. And the DVC uses this to check what has changed. What should we respond to the question? Add to DVC. So the answer is S, which is step into. Unfortunately, Colab doesn't support command line tools very well. So if you press H, it will just cancel the H, which is help, which usually should tell you what the options are. It will instead fail. So you should do S in this case, and I recommend experimenting with FDS locally first. Is this like poetry? I'm not sure I understand the question. You can use DVC to manage large files. So maybe in that sense, it's like poetry because poetry manages packages, but DVC is very optimized for data science, data set and model management. So in that sense, it's not so close to poetry. Is there a way to connect with ML experimentation tracking? So like weights and biases. So the answer is it is very versatile, depending on how you define connect. So you can use DVC and weights and biases in parallel. We have users that are using DAGZUB with weights and biases. So you can definitely log experiments there and log your data to like DAGZUB or some other remote, but there's no built-in integration between weights and biases and DVC, at least not currently. We might build that later. So Matthias is asking, where can we get the notebook? So I'll send the link again. This will scroll you to the end probably. Maybe let me go to the top. But yeah, so this is the notebook. Feel free to use it. I'll share it also in the Slack, and I'll add it to the description of the talk so everyone has it. Any questions, by the way, someone wants to go on and ask it in person? Came for the tutorial, stayed for the Halloween cats. Yes, if you are not familiar with this, go to the Google Colab settings and then go to miscellaneous. And then you have the corgi mode and the kitty mode, very recommended. And now they are in Halloween costumes because why not? And the power level as well. I'm not doing this. You can check it out for yourself. So thank you everyone for joining. It was a pleasure to give this talk and sort of join you today. Please feel free to reach out to me. I will be on the Slack at my name and as well as in GatherTown with my name as well. And have a great day, everyone.